So today's question is called King Activity. The dealer is known to deal cards from a deck that is comprised of 10 standard card decks. This means that there are 40 of each rank of card and 520 total cards. The dealer plays a game where he shuffles all 10 decks together randomly, and then he starts turning over cards from the top of the deck. Once he turns over 5 kings, the game is over. You win the game if you are closest to how many cards total, including the final king, the dealer turns over before the game ends. How many cards would you guess to maximize your chances? Note that this is different from the expected value. Okay, so from this question, what we can tell is that we're kind of dealing with a definitely hypergeometric distribution. And it's actually, in fact, it's called negative hypergeometric because this is not a binomial because we know our dex is we don't get replaced. So that's why it's not the binomial because it's without replacement. And it's geo like hypergeometric because um we care about like how many of the cards there are like basically our success up to the five. So then it's not exactly hypergeometric, it's negative hypergeometric because we care about the success, which is the opposite of um, the number of turns for hypergeometric. So this is just a negative hypergeometric. This is kind of what, doing this question, I kind of had to go over what sort of different distributions measure. Binomial is success in independent trials. Hypergeometric is when we have success in draws without replacement. And then negative hypergeometric is trials until the rth success without replacement. Geometric is the first success with replacement. Negative binomial is trials until the rth success with replacement. So negative binomial is just the extension of geometric with up to the rth trial, up rth success. And then negative hypergeometric is basically when geometric is without replacement. So that's the relationship. And Poisson is the number of events in a fixed time or space. And exponential is the time between Poisson events. So that's kind of it. And then most of these distributions that we're dealing with are discrete, and the only exponential is kind of like a continuous. But Poisson and exponential are not even used here in this question. We're just in this question, we're mainly using negative hypergeometric because we care about up to the fifth success, right? Without replacement, because once we draw the cards, they're not going to be added back. And one thing that's really special about this question is that we want to maximize your chances, and it's different from actually calculating that expected value. Why is that the case? I'll kind of go over that in a bit because expected value doesn't mean that's the guess we want to make because it doesn't maximize our chances. It's just going to be the place that averages out, which is not what we want. So essentially what we're trying to find is actually the mode because whatever we guess, we want to be the closest. So we want to find the most likely outcome, which is the mode. So we're just going to guess the one that happens the most. So in order to guess the one that happens the most, we're going to have to use the PMF for sure. And then we're just going to calculate the probability that P of X equals N, which basically means that we find the position where the fifth king happens, and then that way we can just end it off there. Right. So then we know that the probability mass function is this thing over here. And why is this the case? We can kind of go over the setup. We just basically it's just a counting, just counting the ways that it can happen. So in the first n minus one cards, we have exactly 4 kings, right? And then the last card is the fifth king. And then we have n minus 1 minus 4 non-kings, right? Because we have within the n minus 1 cards, and then there's 4 kings inside, so the rest of the cards are non-kings. So it's n minus 5. So the probability of that happening is first choosing 4 kings from the 4 kings. Then we choose n minus 5 cards from the n minus k cards left inside the cards. And then we're just going to pick the from all of the n's we can pick n minus 1 cards, right? So that would be the probability. And then we know that we have to finish with the king. So with 4 kings already gone, there are k minus 4 kings left. And with n minus one cards already gone, there's this many cards left, right? So then the probability is this. So that's why we have this thing first here that we just first got in the first part, and then we times it by the last card that makes it the king, the probability of that happening. And then this is basically the PMF of our negative hypergeometric distribution. Right, so this is basically what it means. Going to go into a bit more detail. This is basically sampling the fixed number of success without replacement. And then we want to just find that. And then trials are dependent. And then our mode. Next, we're going to just talk about if we know this PMF, we're going to try to find the mode, right? So here the formula for finding mode is equal to this thing over here. Where did this come from actually? So I'll kind of explain that. But the idea behind this is essentially that if we're trying to find the maximum where it happens, then the maximum must be greater than or equal to the one that happened before. And then it should also be the greater than or equal to the one that happened after, right? So that's where we have this peak, right, in the PMF graph. This is the peak, the one on the left, and on the right is all smaller than that. That's the idea. And how we got this formula was just basically if we know that it kind of the probability stops increasing and starts decreasing, then we can kind of set up this equation so that P of x equals n divided by P of x equals n minus 1 is greater than or equal to 1. So that means that we stop increasing and start decreasing. So then we just put back in the negative hypergeometric PMF and simplify the ratio, the thing, and we get this equation over here. And then we just expand this thing, the bottom thing, to the right-hand side. Then we're just going to find n is smaller than or equal to this thing over here. And since n has to be an integer, so we're just going to take the floor of that and plus 1. So that's basically how we got the mode. Um, there's one slight little comment is that what if this thing was actually an integer, right? If it was integer and exactly equal to 1, then what it means would be that this thing was actually bimodal. Like basically, the idea is that it was bimodal. So then we have two peaks. If we have two peaks that are equal, then it doesn't matter which one we pick. So we're just going to round up and pick the second one. So that's the idea behind that. So that's how we got the mode equation. And we're just going to plug in the values. R is equal to 5, N is equal to 520, K is equal to 40. So we're going to plug that in and we get 52 plus 1 is 53. So we have 53 cards. I think it's different from the expected value because if we're just calculating the expected value, it would have been around 60 something. So then it's the same kind of idea from the explanation from earlier yesterday. It was because of skewness, right? Expected value is really skewed to the right. So it has a pretty big tail over here because it just has this tail. And that means that the expected value, because it's a mean, is going to be skewed to the right, also skewed to the right, and affected to be larger. Whereas our maximum value of the peak, where we should be estimating, is somewhere over here, and that should be our guess.